Have you ever done this? You're like staring at a package, maybe some dried fruit or something, maybe even a contact lens solution, and you see that one ingredient,
Yeah,
the one that just looks like it escaped from a chemistry lab. Not the normal stuff like water or sugar, but something really chemical sounding, maybe all capped.
totally. It's like hitting a wall in the ingredient list, right?
Yeah.
And that whole thing, that clash between just buying stuff and this like complex chemistry, that's exactly where we started for today's deep dive.
Right.
We got this really interesting note from someone, a listener, who got totally sidetracked by this one chemical name, sodium bisulfite.
Okay, sodium bisulfite. So let's unpack this. The mission today is basically to give you, our listener, kind of fast track to understanding what NaHSO3 actually is. We want to go beyond just knowing it's, a preservative or something. We're digging into the chemistry, which is surprisingly weird, and just how much this one substance is used across different industries.
And we really, really have to start with the chemical formula,
Yeah.
NaHSO3. Sodium bisulfite, I mean, it looks pretty straightforward, doesn't it?
Uh.
Looks like a normal, properly defined compound, like NaCl, table salt.
It absolutely does. It looks like something from, basic chemistry class.
Yeah.
But here's the thing. The really central kind of mind-bending fact that just jumped out from the notes we looked at, and it's probably what stopped that shopper in their tracks.
What's there?
Sodium bisulfite is, it's fundamentally not a real single compound you can just isolate and put in a jar.
That's the kicker, isn't it? The chemical curveball.
Mm-hmm.
When you actually try to pin it down, try to isolate just NaHSO3, its ill-defined nature, as the chemistry sources call it, becomes obvious.
Huh.
It just doesn't exist as that neat little NaHSO3 molecule stable on its own.
Wait, okay, so if it's not a real compound, why do we write the formula like that? Why label it that way on, food or whatever? Is it just easier, like a convenient fiction?
A convenient fiction. It's not really a lie, maybe more like chemical shorthand for its function. What you're actually dealing with, what you buy, is a mixture. It's various salts containing sodium and sulfur.
Okay.
And the key thing is, the moment you put this mixture into water, which is where it usually ends up, right?
Mm.
In food or an industrial process, it dissolves instantly.
And when it dissolves, what happens then?
So this is crucial. It creates a solution that's full of sodium ions, okay, but more importantly, bisulfite ions, HSO3.
Ah, okay.
And those bisulfite ions, they're the active part. They're what actually do things. So while we call the solid stuff sodium bisulfite, the formula NaHSO3 is really just describing a solid that reliably makes those powerful bisulfite ions when you dissolve it.
So when I see that name on an ingredient list, I shouldn't picture some little crystal just sitting there.
Exactly.
I should picture a chemical process happening right there in the product, kicked off by this salt mix. It's active.
Precisely. It's an active ingredient system, not a static lump. And even though it's getting that, chemically ill-defined thing going on, the mixture itself has some very specific kind of hard-to-miss physical properties.
Yeah.
You know it when you encounter it.
Okay, let's switch gears a bit. Sensory stuff. If I had the pure crystalline form of this mixture, what would I see? And maybe more importantly, what's the smell like?
Visually, the sources describe it as white or maybe slightly yellowish white crystals. Pretty standard chemical look, and nothing too wild there.
Right. But the smell is the giveaway, isn't it? I bet people have smelled this before, even if they don't know the name.
Oh, yeah. It has that distinct odor of sulfur dioxide.
That sharp, slightly prickly smell, like burnt matches almost.
Exactly that. That's sulfur tang.
Yeah.
And that smell links directly to its most common job, the one most consumers might know. The food preservative.
Right?
When it's used in food, this very active ingredient stops spoilage. It works in two ways, really. It's antimicrobial, so it kills off bacteria and molds you don't want. And it's also an antioxidant. It stops the food from reacting with oxygen, which is what makes things like dried fruit turn brown or oils go rancid.
And for anyone who pays close attention to labels, especially maybe European ones, there's a code for this, right?
Yep. It has its own E number. In the context of food, it's standardized as the additive E222.
E222. So if you see that, you're looking at sodium bisulfite doing its preservative thing.
Exactly. But what's really fascinating, though, is just how narrow that food preservative identity is when you look at everything else it does.
Okay.
The fact that it's so reactive that it generates those bisulfite ions so readily, that makes it a well, an absolute workhorse chemical in industries that have nothing to do with food.
This is where it gets really versatile, isn't it? And where that idea of a complicated identity really clicks. We need to kind of step away from the kitchen for a minute,
We do.
because the notes we saw highlighted two other huge, completely different industrial uses that show just how powerful this stuff is.
Yeah, absolutely. The first one takes us into cosmetics, the cosmetic industry.
Okay. Here, sodium bisulfite acts as something called a reducing agent.
Okay, reducing agent. For those of us whose chemistry is a bit rusty, what does that mean in practical terms, like in a shampoo or a face cream?
Well, think of it like this. Reduction, chemically speaking, is about gaining electrons. A reducing agent, like sodium bisulfite, is the substance that donates those electrons.
Right.
In cosmetics, this is super important for keeping formulas stable, things that might otherwise break down or react. It helps control the chemical environment inside the product.
How so?
Well, it makes sure that certain sensitive ingredients, maybe vitamins or fragrances, things like that, keep their structure and their effectiveness over the shelf life of the product. It's like the invisible scaffolding holding the formula stable.
So it's basically a stabilizer. It makes sure the product you buy today still works and feels the same 6 months down the line. That sounds totally different from keeping a raisin from going brown. It is a completely different function. But then there's the second major industrial role, and this one takes us even further away into cleaning, manufacturing, even environmental safety.
Okay.
This is its job in the bleaching industry.
The bleaching industry. And the note said it's used as what was it? A decomposer of residual hypochlorite. That sounds very technical and maybe a bit hazardous.
It's highly specific, yeah.
Yeah.
But it's incredibly important for safety. Hypochlorite, that's the really active, strong chemical in chlorine bleach.
Right, like household bleach, but maybe stronger?
Often much stronger, yeah. If you're making textiles or paper or even treating wastewater, you often use hypochlorite to bleach things or sanitize them. But the problem is, you absolutely cannot just let that powerful corrosive chemical stay active. Not in the finished product, and definitely not going down the drain into the environment.
So sodium bisulfite is like the cleanup crew. It comes in at the end.
That's a perfect way to put it. It's the chemical cleanup crew. Sodium bisulfite reacts really fast with any leftover hypochlorite, neutralizing it, decomposing it. It basically slams the brakes on the bleaching reaction.
Wow.
And this does two things. It protects rivers and ecosystems from dangerous chemicals in the wastewater, and makes sure the final product, like cloth or paper, is stable and safe for people to handle.
Okay, my head's spinning a little. So we started with this functional name for a salt mixture that isn't really one thing.
Right.
Then it's a food preservative, E222.
Yeah.
Then it's a stabilizer in cosmetics, like eye cream. And then it's also the emergency stop button for industrial bleach.
Yeah.
That is one heck of a diverse resume for something that's technically not even a single compound.
It's that sheer range of applications, that versatility, that makes how it's labeled and disclosed so important.
Yeah.
And that brings us right back around to why the original shopper noticed it in the first place.
Right, the context. The listener's notes said they found this ingredient highlighted on a package specifically marked as a foreign food product, and it was subject to apparently stricter regulations. The key observation was that because of these rules, that package had much more detailed warnings or disclaimers than they usually saw.
And this is where the chemistry suddenly bumps up against, well, regulatory awareness, doesn't it?
Yeah.
The reason for those detailed warnings wasn't about the chemical itself. Sodium bisulfite is the same stuff everywhere. It was about the rules applied to that specific category of product, the imported good.
And the big question the shopper raised, the transparency issue, was basically, do similar local products, which have the exact same E222 sodium bisulfite in them, do they give consumers the same level of detailed information? Same warnings?
It really makes you pause, doesn't it? It forces you to ask. Is the information we get about what's in our products decided more by where it came from or its trade status than by what the chemical actually is and what it can do?
Yeah, it points to a potential gap, maybe. An inconsistency in how we're informed as consumers. If a chemical that's powerful enough to neutralize industrial bleach and stabilize cosmetics needs a detailed disclaimer when it comes from overseas,
Right.
shouldn't we get that same level of detail on the equivalent product made right here?
You'd think so. The author's observation is almost like a perfect little case study of how sometimes information systems can hide things in plain sight. We sort of assume that if it's on the local shelf, it's fine, all the checks are done, and maybe we don't look as closely. The imported product, just because it fell under different rules, accidentally gave a clearer, maybe more honest picture of the ingredient's nature.
So let's try and wrap this up. We started with just a confusing name on a label, NaDHSO3.
Hmm.
We found out it's really chemical shorthand for a mixture that makes active ions in water. We've seen its different jobs. Food preserver, E222, cosmetic reducing agent, industrial bleach neutralizer.
And we finished by linking those chemical facts straight back to the world of regulations and labels. The fact that the disclosure level can change so much based on whether it's local or foreign, that tells us a lot about how we get information, not just about how we get food.
It definitely makes you want to read labels more carefully. And maybe as a final thought, something to chew on, building on that idea of regulatory knowledge versus scientific knowledge.
Yeah.
How often do we use things that have these kinds of dual or even multiple identities? If something as common as sodium bisulfite can be both a food additive and basically an industrial safety chemical,
Right.
what other things in our cupboards, regular household stuff, contain substances with these really varied, maybe even contradictory roles that the standard local label just isn't prompting us to think about?
That is an excellent challenge for everyone listening. The next time you scan an ingredient list and see a chemical name you don't quite recognize, maybe remember sodium bisulfite.
Yeah.
That name might just be the visible tip of a surprisingly large, powerful, and chemically complex iceberg.
Definitely something to think about next time you're in the supermarket aisle. Maybe comparing an imported jar of something with the local version. Okay, that's it for this deep dive.